Hi students, in today's session I am going to discuss about electronegativity. So the electronegativity, it's nothing but here that atom A and atom B. So the atom A, it tends to gain electron. So the first curl without a cap is an A and with cap is an B. So electronegativity, it's nothing but the ability of a covalently bonded atom to attract the shared electrons towards itself is called an electronegativity. So let us see with an example. Okay, so the cap without a girl is an atom A and a cap is an atom B. Okay, girl with a cap is an atom B. Okay, so the atom A is going to gain an electron from an atom B. Here the atom and A and atom B may be a metal or non-metal, okay, or a bonding between two non-metals. Okay, so it depends upon the electronegativity between the two atoms, the outermost shell of an atom. Okay, so the atom A is an electronegative because it tends to gain an electron from an atom B, and atom B is an electropositive. Okay, so that electronegativity. So the atom here have a weak pull and atom have a big electronegativity difference, which means a big electronegativity difference between atom A and atom B. It because of the outermost electron present in the outer shell. If an atom A, it contains a 1 electron, it tend to lose a electron to atom B. If atom B contains a 7 electrons, it needs one more electron to attain the stability. So the one electron can be taken out from that atom A to make that to make a bond strong. Okay, so this we call it as an electronegativity. So the atom A, it donates an electron to atom B. Okay, so there will be a strong pulling between atom A and atom B. So finally the atom B, it contains a 7 electron in outermost shell, so it tends to elements gain electronegativity. So now see the electronegativity from hydrogen 2.1, lithium 1, beryllium 1.6, sodium 0.9, magnesium 1.2, like that boron 2.0, carbon 2.5. So you can observe that from left to right the electronegativity is increased, so that they indicate a low, medium and high in arrow mark, which means the left hand side they have an low electronegativity and right hand side elements have an high electronegativity, because starting from left to right depend upon a periods. What you observe, that is the number of electrons increased each and every element, for each and every element. For lithium the number of shells is 2, like that the beryllium also 2, but the number of electron goes and extend. Okay, so that the nuclear charge, the positive charge which is responsible for a nucleus, okay, so it get attract the electron present at the outermost shell. Okay, so there will be a contraction between electrons and the nucleus. So what will happen, the electronegativity gets further that increases. If a effective nuclear charge the increases, the nuclear charge, it's nothing but so the how much the electrons can be pulled by a nucleus. This we call, so that the force between a positive and negative charge, which means the outermost shell electrons and in between the nucleus. Okay, so there will be a great attraction between this. If a number of electrons it increased in the outermost shell, so that attraction between a nucleus and outermost shell it contains an electron will be more effective. So this concept we call it as an effective nuclear charge. Okay, if effective nuclear charge is high, then the electronegativity also high. So that we observe that from lithium to fluorine the electronegativity get increased. Okay, so now see the character of that some compounds. So non-polar, it is a covalent bond, made by a covalent bond. Electrons are shared equally. Okay, so the next is polar covalent bond. Electrons are shared unequally, okay, because here the hydrogen have a low pull, okay, weak pull, and chlorine have a strong pull, okay. So the electronegativity among this hydrogen and chlorine, while compared with these two elements, chlorine have a high electronegativity. Here the chlorine have a outermost shell, it contains 7 electrons, so it tends to pull electron. If we break down the hydrogen chloride, so the hydrogen will be a plus and chlorine will be a minus. So no need to be confused with that ionic bond. This bond is made up of a covalent sharing only, but regarding to the electronegativity, if we break the bond between a hydrogen and chlorine, so which one tends to gain an electron and which one tends to lose the electron, that's the difference. So here the bond is made by a covalent only. If we break that covalent bond, hydrogen tend to lose electron and chlorine tend to gain electron. So which one have an high electronegativity? Chlorine atom have an high electronegativity. Like that ionic bond, electrons are transferred. It's going to be transferred from one atom to another. But here will be a difference between the two atoms. So the bond between the two atoms, it's covalent bond. But which one have an high tendency to gain or lose the electron? That's a concept. That's a new concept arise between the two atoms. Okay, so that we call it as an electronegativity. So we almost see that. The electronegativity of a chlorine Cl2 is up to 0.4, like that HCl up to 1.8. Okay, so this is an electronegativity. So this is an electronegativity values of some common elements. So this an increasing electronegativity starting from left to right, and here up to down. Okay, so here the arrow mark, it goes and up. Okay, so the increasing electronegativity. Okay, so now see from left to right, starting from lithium to fluorine, number of electrons will be added one by one. Okay, so lithium atomic number is, you almost know, 3. Like that beryllium is 4, boron 5. So what will happen? The number of electrons get increased in the same shell only. So the number of shell in lithium is 2, and like that the beryllium also 2 and boron also 2. But the electrons, the counting of an electrons is increased. So what will happen? The nucleus, it have a positive charge and the electrons have a negative charge. It have a great tendency to share the electrons. Okay, so that we call it as an electronegativity. That par we call it as an electronegativity. So the ability of an atom have a tendency to gain electron from a shared pair of electrons. Okay, so it may be shared a electron between a two atom. It's nothing. It's no matter, but how does the atom have a capacity, whether it lose or it gain? Okay, so it depends upon that the electronegativity difference came arise. Okay, so the electronegativity, it's nothing but the ability of an atom having a tendency to gain an electron from other atom. Okay, so that we call it as an by a covalent bond. Okay, getting from that covalent bond only. Okay, not from an ionic. It almost transfer of electrons, but covalent there will be a sharing of electrons. If we break that bond, what will happen? Which one have an high electronegativity? It gains electron. Which one have a lower electronegativity? It tends to lose the electron. That's a concept here, that electronegativity.